Welcome to Shop Bench, and today I'm going to be putting together another little LED kit that I got from AliExpress. This one's going to be a little bit more challenging because it looks like a combination of surface mount and through hole components. Looks to have a couple of surface mount chips and several what look to be surface mount resistors. And I thought I'd give this one a go just to get some practice on doing some surface mount soldering. So we'll take a quick look at the actual module itself. And this is described as the Smart Electronics Kit NE555 plus CD4017 Light Water Flowing LED Module DIY Kit for the exorbitant price of 42 cents with 16 cents shipping. This is just one of those things that I just threw onto some order that I was doing at the time. Again, just to have something to practice soldering to, with, etc. Sharpen those skills before I need them on something actually important. Now, I'm going to guess with it being a 555 timer, something periodic is going to happen. It's going to cause these LEDs to light up in some sequence, I would imagine. I'm resisting looking up exactly what it does. Here's the schematic. I want it to be a complete surprise when I finish, so hopefully once we get it all soldered and put together and we power it up, that the board will give us a treat and show us something interesting. Again, another little piece of visual interest and just a kit to practice on, dirt cheap. So we'll just go ahead here and we'll just pop open the kit itself and see what it looks like we have. We have a number of resistors, two capacitors here. This looks to be the CD4017. This one looks to be the 555 timer. We have another resistor of a different value, and again third resistor of a different value there. So it looks like we have a bunch that are all the same, which I would imagine are going to be these current limiting resistors for the LEDs. And then it looks like we have a position on the board for two resistors here, R2 and 3, 10k and a 2k. The current limiting resistors all look to be 1k, and then a position for the two capacitors, C2 and C1, 1 microfarad each. And it looks like we have a pin header here for power. And it looks like we have a variable resistor, 50k variable resistor, which I imagine the variable resistor, these resistors and capacitors here will control the timer, the rate of the timer, I'm going to guess. This capacitor over here looks like a decoupling capacitor for the chip. The chip itself looks to be 16 pin, and then the 555 timer is an 8 pin, so it's a good opportunity to practice a little bit of surface mount here with some smaller pads and some smaller components. And I will be hand soldering these rather than trying to do anything with paint or hot air, because again, as I said, I just want some practice at actually soldering components of this size, as I haven't really done a lot of it, and it's something I'd like to get a little bit better with. I just need to grab my magnifying glass so I can tell which one of these resistors, which one is the 10k and which one is the 2k. Taking a look, that's 202, so 20 and 2 zeros, that would be the 2k, and then 103, that would be 10 and 3 zeros, that would be the 10k. So I'll put 2k, 10k, and that's the set of 1k resistors. And we've got the capacitors, the chips, the LEDs. So we will start with the surface mount resistors and capacitors, as those are the lowest profiles, the ones I want to get. Let's warm up a little bit before we start tackling the chips. Let's do a couple of the surface mount resistors and capacitors first. Just gonna need some fine solder for this today. Not sure I've got the right size tip on my soldering iron, but we're going to give it a whirl with the one that's already on there, because that's one of the things that I need to work on with my soldering iron skills, is just being able to make the most out of the tool that's in front of me. You can't always stop and change anything. My first inclination would be to stop and put a smaller tip on this. I do actually have a smaller tip, but honestly I don't really want to wait for the whole thing to cool down and then try changing the tip and then soldering. I'd rather just crack on and see what we can do. So I'm just going to tin the far side of each of these pads here for these 1K resistors, and we'll go with the method of tacking down one side and then buttoning up the other side, and then reflowing the first side if needed. So there we go. That's that. And I like to solder on the right hand side, so I will be holding from the left with the tweezers, positioning, and then reflowing on the right. So let's go ahead and start pulling out these resistors here. Get them all ready to go. There we go, let's get the film started. Shall we be brave and just spill them all onto the mat? I think we will. There we go. Now these look like they are 0604s maybe? I don't think they're all 402s, I'd have to look, but there we go, that's number one down. Number two. Number three. Four. This is going deceptively easier than I would expect. It doesn't normally go like this. I normally squeeze the tweezers and resistors are pinging off left and right. I think it's being kind to me because people are watching me. There we go. And again with this one, I haven't tested the LEDs. I'm just gonna hope that they all work and want to be surprised by the result. So what's the fun in knowing ahead of time it's going to work, right? Well, at least with a kit like this, half of the fun is just the surprise. There you go. See, that was a bit more like how my experience normally is with these small components. Not very skilled with my left hand, so there we go. That's all the sides tack soldered on. So let's now anchor them all in place on this far side. and go back to the original side, make sure that there's just enough solder on there to get a nice connection, because I wasn't particularly generous when I tinned the pad. Just enough to adhere half the component to. There we go. Forgive me 1 second while I just take a look at these joints, see if they look okay. You probably won't be able to, maybe you can see a little bit through there. Actually don't look too bad. I'm surprised. Not too bad at all. Alright, well, now let's move on to the 2K and 10K. Which way did I put them around? That's 10K on the bottom. Here's my 2K. 2K is R2 right here. 10K, R2, R3 right there. Might as well just tin up the two capacitor pads. And while I'm at it, I will tin this bottom left pad here, bottom right pad here of, I believe it's going to be some kind of a counter chip, and then this timer, so I'll be fixing bottom right, top left, and then going down doing the rest of the pads. Just pre-tin those there. Alright, so we do this 2K first. Don't know if anybody else struggles getting things out of these cut tape packages. I don't find them the easiest thing to work with. I either pull on them too hard and they go flying everywhere, or I struggle to get a good grip on them. There we go. Let's get my 2K. That one down. Let's go ahead and get this 10K. There we go. Flip that one over. 10K. Down there, right? Let's get our two caps. Just open that up there. Done. Now with these, I'm conscious of the fact that heat is one of the ways to damage these types of capacitors, so I don't want to be lingering too long. Oh yeah, there we go, get that one on. And then over to here. Hey, not bad. Not bad. This is actually something horrible will have to go wrong with this build, because the soldering itself is actually going quite well, and that is not usually the case for me with these surface mount components. Although, you know, it's highly possible I just got a little bit better. Oh, I didn't wet the pad. Okay. That one's a bit better. Okay, so it seems like the secret was going in and feeding it from the bottom a bit more. And I'm just gonna whip through, just make sure I've got enough going on here. hold it down now that it's down. Alright, here we go. Should we go with the big chip or the small chip first? How brave are we feeling? Well, I think we'll go with the big one. Let's go with the big one. So the small one should be a walk in the park. So, where are you, pin 1? So pin 1 on this device. It's right there. It's top left hand corner. I don't think you can see that there. Maybe we can. I doubt very much you'll be able to make that out, but the pin's in his top left corner. And according to the silk screen, that belongs up here. Now, I did not use a flux pen, which I may come to regret in a minute, especially with these small legs. I found when I'm soldering I have to not only tiny top, but I actually have to put just a little bit of pressure. It's a bit difficult. I find that sometimes if I'm not putting a little bit of pressure on the chip, it will stick to the soldering iron. Well, that's not too bad. It's not quite the straightest. Let's see if we can. Maybe should be able to flex that just a little bit. Actually, not positioned too terribly. But what we'll do is we'll put a bit of solder on this pad, and then we'll see if I can just flex it a little bit. Straighten it up. Ah, that's not too terrible. You know, that'll do. That will do. Alright, let's see how we do on these legs without the flux on. Flux would definitely have helped. Especially with this fatter tip on here. Not too bad. Might get away with it. Keep your fingers crossed for me. Really do want this one to be a little bit of a quicker build than last time. Last time took longer than expected, but was a satisfying result in the end after I had replaced two or three LEDs. I think it was 3. I had to replace 2 of them on the hourglass, and by replacing one of them it kind of fixed the other one, so I imagine it was probably Charlie plexed, and it was just the one bad LED that was killing both of them, and I think I just got lucky on which one I replaced and fixed, and it happened to fix the other one. Get it smelled up on something there. There we go. This chisel tip's not really the greatest for getting extra solder off the pins. There we go. Let's get them soldered down, and then I'll try and clean up the pins just a little bit. Yeah, because that's not the nicest solder job on there, so we'll see if we can just stroke some of the solder off, some of the excess off. Actually, it doesn't look too terrible for the degree of effort put in. Let's whip out the magnifying glass and we will take a look, see how I like the look of these. I'm not seeing any solder bridges. Looks like it's wet the pads all the way down. This side looks a lot better. Alright, so there's one ugly pin on this one. This third one here has got a solder blob sticking out. There we go. Alright. Let's go with the timer now that we're all warmed up with that one big chip. Hopefully this one will be a walk in the park. And again, we are looking for pin 1 and pin 1. Shoot. Pin 1. Go there. Double check. Pin 1 to pin 1. Let's get this lined up here. I've wondered whether or not you could use solder paste to do the just initial tacking down. I don't know, I've never tried that, you know, sticking the soldering iron onto soldering paste to tack solder that first pin, because I think it would lie a little bit flatter. So, because one of, you know, imagine I'm putting this pin on here now, and this first pin, this bottom right, is riding high a little bit, so the whole chip is now, you know, not flat. I just wonder, would it be easier because you could push it down in, I guess, you know, if you imagine just having that bit of solder paste pushing the leg into it, then it would be flat. It wouldn't, because when I push down with the tweezers onto the tinned pad, it's a little bit raised, so the leg wants to roll off, so to speak. Right, got some corners on, let's get some solder on the rest of these pads. Trying to get the soldering iron in contact with both the pin and the pad, so that it heats them both up and get the solder to flow as best we can under it. Oof, chip gets hot. Try and do it as quickly as possible. As luck would have it, I actually have more of the 555 timers, so if I break one of those I can replace that. I don't think I can replace the other chip though. We'll have to look that one up, see what exactly that chip is. Just tidy these up a little bit, get a bit of excess solder off the... There we go. A bit better. Let's take a look at that one under the magnifying glass. I don't see any bridges. Looks okay. Looks like it's wet, the pads and the pins. And pin 1 is to pin 1. Pin 1 is to pin 1 there. Alright, moving on. Let's think. Well, let's see. Which of these is gonna... Oh, that's definitely gonna stick up further. Alright, so we're gonna go with the LEDs next because they're lower profile. So it looks like this end here is positive. On the symbol you can see we've got our diode symbol. So we've got the positive here, negative leg here, positive being the longer leg, negative being the shorter leg. So we're going to want to populate this with long legs all on the left. we could probably just pop them all in and turn it over, and then we'll probably do what we did with the hourglass, just solder one leg, ensure it's flush, and solder the other leg. 3, 4, 5. So it looks like it's 10. So I imagine that might be a decade counter then. So I'm going to guess, at a guess, with it just being a simple timer, it's probably going to be just a normal square wave generation to clock the counter chip. And I imagine, it's just a wild guess, could be wrong, was more wrong than I imagined what was happening with the hourglass one, with the final result, but it's probably just going to go scan right to left to right, and I imagine we can probably change the speed with the variable resistor. Alright, so these are going to be angled at first, and then we'll go in and straighten each one up. One second. I don't need this short solder, let's get some bigger solder. We're feeding it all day on these big pins otherwise. There we go. Let's tap the one leg on. Now for power supply, I'm probably just going to cannibalize that USB cable that's on the hourglass project, mostly because one of the leads detached itself after I took it into work and I needed to fix it. I will quickly cannibalize that lead rather than put the header on first, just to test it with some power, just to see if it works. Now, I think it can work with anything up to like 14 volts, so like something like 4 volts to 14, something along those lines, which is quite a big range. But then that's just standard logic chip voltages. It doesn't need anything as delicate as like 3.3 volts, like some awkward microcontrollers, etc. I mean, I say awkward, it's just that I don't have a plethora of 3.5 volt power supplies just lying around, so I always have to do something with a 5 volt and step it down to 3, so it's an extra piece of bother. So I like it when something's just straight, oh, it's 5 volts. One of the reasons why I love Unos and Nanos, because you don't have to do anything special with them power wise, you just plug them in. It makes them ideal for using them to verify and test or do the first initial blush of a project with them, because it's one less thing to mither around with, because you can plug in your 5 volt power supply and almost any charge is going to give you up to 2 amps. That's enough to power even NeoPixel strings if you pigtail off the power, which is definitely easier than having to mess around with 5 volt and 3.3 volt. There we go, they're looking. Look straight enough. That one looks a bit skew. There we go. They look alright. Alright, let's touch more solder. Let's get these second legs in. Now, an immediate project need I'm starting to find, given them doing a lot of LED projects would be something to be able to test LEDs with, just to make sure that they're working before I solder them in. So that would have saved me a little bit of hassle on that last hourglass project, but you know, I just wanted to crack on and get going with it. But I'm thinking for that clock that I didn't choose, there's at least 60 LEDs on that one, and I actually don't like the colour of the LEDs that came with it, because it came with red and green, and I'm thinking I want something more like blue and orange. So it's this kit here, comes with red and green, quite a few of them, but I actually just got some 600 3mm LEDs of 5-6 different colours. I'm going to use one of those colours instead, probably blue and orange, as I say. Let's trim these down. Let's be brave. Trim them all down, because if they don't work, I can always put a different one in, because I've got a bunch of red ones, so now I actually do have some replacement, because these are just diffused red. They're nothing special like the hourglass ones. They were a clear blue, which I didn't have any spurs, but luckily the kit came with the 2 extra, and that was exactly enough to be able to replace the 2 that weren't working for whatever reason. Alright, there we go. So what are we looking at now? Just this variable resistor. And 3. Well, that's not very straight. Let's quickly heat these 2 up. 3 up. There we go. It's a bit better. There. That's better. Just wasn't so flush. Looks alright. Right, just need the power. So I need to liberate this power lead. To strip this back, tin it, and I'm just gonna solder it onto here, and then we'll give it a whirl. Alright, so let's just trim this down. Strip off the end, and this is just temporary, so I'm not going to go to great pains here. Just get enough to solder it down. I'll just tin these quick. The purpose of these projects, again, as I've said before, is just to do something to practice some skills and to just be quick, you know, not something deep and involved, but just a nice reason to sit down, do something, and have something visual at the end of it while I practice some skills and decide what actual projects I want to do, which should be, we'll have a discussion on in the not too distant future, as I'm thinking actually just will. I don't want to do this. Yeah, I can always suck the solder off later. Just going to tin these pads here. Alright. Do it this way around. Positive. Negative. Let's just make sure that end there is not touching anything. Alright. Moment of truth. Moment of truth. Let's see. Will he work? And there we go. And it's doing exactly what I predicted at the beginning. So it looks like this is a 555 timer that's then clocking a counter chip. And if I guess correctly, changing. That's not going to fit in. Changing this variable resistor should change the speed, I'm guessing. Yeah, see that's slowing down. Here we have looks like we have one LED that does not want to work. So it looks like this LED here is not cooperating. There we go. Just wasn't making good contact on the pad. Perfect. And that is the amazing LED 555 timer light water flowing LED module. That was a nice little kit to practice soldering. It's about the right size. You know, you had 10, 14 SMD resistors capacitor sizes to practice with, and you had an 8 pin and then a 16 pin chip, and then you had the through hole LEDs and a potentiometer. So it was a nice mixture of soldering approaches, you know, coming in with the just the 2 terminal devices all the way through, and that was good practice. I didn't mind that. What I will do very quickly is just desolder these power leads. I'm going to put them back on the hourglass, and I'm just going to show you the fixed hourglass project, because it actually looked very nice when they were all on there. And then I think we decided last time that this side is positive and this side is negative. So we'll just very quickly tack on that negative, tack on that positive, turn it off. I'm just going to plug this in. Alright, don't make a fool of me. There we go. So the power button, the button there changes the speed. As you can see, they're all, the LEDs are actually lighting, so that project worked nicely in the end. It really is quite bright. It doesn't look blue at all underneath the camera, but it's a really nice looking blue when you look at it head on yourself. I really like that one. And there we go, another bit of ornamentation for a desk of some description. I hope you enjoyed following along with me while I put that together. Certainly enjoyed putting it together, you know, for less than $1. The entertainment value, it'd be hard to argue with something else as a, you know, dollars per hour's entertainment. That was a nice teaching experience. A few more of these, a few more kits, you know, and the skills to get strong and build confidence. So Thanks for joining me, and I will see you for the next thing that I build.